Hello class, so today we're going to take a look at trig derivatives. So we've already learned two of them, but we're going to take a look at the other four. So if you take a look here, here is a list of some of the trig derivatives that we'll be using. So from before, we've already done the sine and the cosine one. So we've memorized that the derivative of sine is cosine and that the derivative of cosine is negative sine. So if you take a look, these kind of work in pairs. So tangent's derivative is secant squared of x. Cotangent's derivative is negative cosecant squared of x. Secant's derivative is secant of x tangent of x. And cosecant's derivative, let me use blue here, is negative cosecant x cotangent x. So these are derivatives that you're going to need to remember. But I want you to see the pattern. So if you take a look, if I pull up my highlighter, everything that has a c, so cosine, cotangent, and cosecant, all have derivatives that are negative. There's a negative sine, a negative cosecant, and a negative cosecant cotangent. But the other ones, sine, tangent, and secant, which do not start with a c, have positive derivatives. So that's one way to remember which derivatives are negative and which derivatives are positive. So this is something you'll have to commit to memory. So let's prove some of these to show you why it works. This says prove the following using sine, cosine, and the quotient rule. So what I'm going to do is I'm going to make this just a tad bit smaller. And I'm going to have the derivative of tangent is equal to secant squared of x. So that's a property on the previous page. But let's actually find out why this is true. So what I'm going to do is I need to rewrite them so it's a sine and cosine, and I'm going to want to use the quotient rule. So in order to do that, I'm going to change this to d dx, which means take the derivative of this function. And the property is tangent is the same as sine of x over cosine of x. Now that I have this, it tells me to use the quotient rule. Well, am I allowed to use the quotient rule now? Yes. So let's do our rule. We get the bottom times the derivative of the top. Derivative of sine is cosine of x. Minus, oh, I'm missing an s right there, minus the top, which is sine of x, times the derivative of the bottom. Well, derivative of cosine is negative sine, so that's going to change this to a positive, and I'm going to get a sine x here, all over the bottom squared, which is cosine squared of x. Is that correct? Okay, so I'm going to simplify this, and I get cosine squared of x plus sine squared of x all over cosine squared of x. So if you take a look at this, I'm going to scroll down just a little bit. You've learned the property to simplify this. So from last year when you guys had to memorize all those trig identities and trig properties, if you can remember, what's cosine squared of x plus sine squared of x? So if I highlight this, this property, right, is actually the same as 1. So if you look back into your textbooks or you look back into your notes from last year, that is 1, which means I can put a numerator of 1 over cosine squared of x. And I can actually rewrite this because we know what cosine squared of x is if I wanted to simplify this. So if I extend the page, we do know that 1 over cosine of x is equal to secant of x. So using this property, I can rewrite this as secant squared of x. So if I follow the whole thing, I get the derivative of tangent of x. We have just made our first calculus proof. That's equal to secant squared of x. Good. Let's prove one more. So once again, it says prove the following using sine, cosine, and the quotient rule. So I'm going to need to rewrite our secant of x into a quotient, and thankfully that was the property that we just used previously. So this is the same as d dx, the derivative of 1 over cosine of x. Have I just created a quotient? Yeah, so now I'm going to use the quotient rule. So the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, which is negative sign. So that gives me a positive sine of x all over the bottom squared. So cosine squared of x. If you notice, since this is a 0, I'm going to cancel that out. And what we get is sine of x divided by cosine squared of x. Well, we need to simplify this so it matches our property over here. So what I'm going to do is I'm going to break this up, and I'm going to say that I have a sine of x on top sine of x on top divided by 2 cosines on the bottom. Okay, so if I take a look at this, don't we know that sine over cosine is the same as tangent? So I'm going to write on here tangent of x. We also know that there's an imaginary 1 here. So if we take a look, what is 1 over cosine of x? Well, that's secant. So I can then write secant of x right here. And we have just proved that the derivative of secant of x is secant x tangent of x. Good. So let's actually use these derivatives and see how they are used. So there is one thing we're going to take a look at, and that is how do I take the derivative if it's not just an x after the trig sign. So for example, this says tangent of 4x. So what I want you to write down is this rule. If I'm taking the derivative of a trig function, it's, and like I said, here are my little odd things that kind of help you remember. But the derivative of this is the derivative of the word times the stuff times the derivative of the stuff. So I am going to explain what I mean by derivative and stuff and all those different things. So please make sure you write this down because it will help you when you're dealing with these problems. So let me shift this into the right place. And I want to shrink it down just a little bit. Okay. So keep this phrase in mind and I'll show you how it's used. So if you take a look at this problem, the first thing you should notice is we're not just using a trig function, we actually have to do a little bit more than that. So what rules do you see in here? I do have a power rule because of that cubed. I also have the trig rules, but since I have a product, I also have to use the product rule. So here's my first, and here's my second. So if I start this, we get f prime of x is equal to the first term times the derivative of the second. And so we're going to use this phrase to take the derivative of that second portion, and I'm going to just scoot this over a little bit. So it says take the derivative of the word, so I'm going to take the derivative of tangent. So the derivative of tangent is secant squared x. So in our case, it's going to be secant squared. Then it says times the stuff. So my stuff is the stuff after the word. So in here, I'm going to use 4x as my stuff. So when I go back in, I'm going to put a 4x right here. Then it says times the derivative of the stuff. So I need to take the derivative of that 4x. And so the derivative of 4x is 4. So I'm going to put a 4 over here to keep that in our rules. And then I have to finish off the product rule. So I get plus the second term, which is tangent of 4x, times the derivative of the first, which is 3x squared. So if I simplify this, I'm going to get f prime of x is equal to, I'm going to move this 4 to the front, so I get 4x cubed secant squared, and just for the sake of keeping things in order, 4x plus 3x squared tangent of 4x. So not only did you use the trig derivative, but you've also taken a power rule and a product rule. Let's take a look at another one. So I have the cotangent of x divided by x. So what rules do we need to use here? Good, I have a quotient, so that means I need to use the quotient rule. So I get g prime of x is equal to the bottom times the derivative of the top. Well, the derivative of cotangent is negative cosecant, so I'm going to put a negative out here and put cosecant squared of x minus the top, which is cotangent of x, times the derivative of the bottom, and the derivative of x is 1, so I'm going to just leave it there, divided by x squared. And that's it for this problem. I would like to skip these two problems after we've learned the chain rule. So if you take a look, this power on cosecant is larger than what we've been using. So we'll skip this and this problem until we learn the chain rule, and we'll go back to it. But I want to do a tangent line, normal line problem. So everything is the same except now I have trig in my functions. So step 1, like always, is if I have an x, I need to find y. So step 1, find y. So we're going to plug this in, and I get f of pi over 8 is equal to cosecant of 2 times pi over 8 plus cotangent of 2 times pi over 8. And if we take a look at this, I think I forgot my 8 right there. I simplify it and I get cosecant of pi over 4 plus cotangent of pi over 4. So you're going to have to solve for these. So whether you memorize them or you learn how to do this with a graph, let's actually take a look and see what this is like. So I'm going to draw my little graph right here. If I do all students take calculus, pi over 4 is in this quadrant, right? So I'm going to make my little triangle. Since I am in A, that means all my answers have to be positive. And if I take a look at this, here's my angle of 45 degrees, or pi over 4. And if you remember your common triangles, I know this is a 1, this is a 1, and this is square root of 2. So that's a 2 right there. So let's use our SOHCAHTOA. Well, cosecant is 1 over sine. So if I take a look at sine, I get OH. But since I'm looking at cosecant, I need the reverse. So I need the hypotenuse over the opposite. So my hypotenuse is square root of 2 over 1. That gives me square root of 2. If I look at cotangent, cotangent is the inverse of tangent. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite. And in this case, our adjacent is 1, our opposite is 1, so that gives me a 1. So according to this, y is equal to radical 2 plus 1. There's step 1. Step 2 is to find the derivative. So let's go back up and find our equation. So cosecant 2x plus cotangent of 2x. I'm going to create a new page. And let us split our page just so you can see the two functions. Okay. So I want to scoot this over just so you guys can see everything. Okay, so if we do this, step 2 is find f prime of x. So I'm going to take this derivative. F of x is equal to cosecant of 2x plus cotangent of 2x, right? So if I take the derivative, to take the derivative of a trig function, take the derivative of the word. So the derivative of cosecant is negative cosecant of the stuff, which is 2x, cotangent of 2x, right, times the derivative of the stuff. So the derivative of 2x is 2, so I'm going to stick that 2 here. Now I'm going to take this derivative, so I get plus the derivative of cotangent is negative cosecant squared. So I'm going to put negative cosecant squared of my stuff, which is 2x. And then I want the derivative of that stuff. So the derivative of 2x is 2, and I'm going to stick it right here in front. And if I fix this up a bit, I get f prime of x is equal to negative 2 cosecant of 2x cotangent of 2x plus minus gives me minus 2 cosecant squared of 2x. So are we okay so far? Alright, so now all I need to do is plug in, all I need to do is plug in my pi over 8 so I can find the actual slope. So let me put a new page in here, and if we do that, we're going to get f prime of pi over 8 is equal to negative 2 cosecant of, we know that 2 times pi over 8 is pi over 4, cotangent of pi over 4, minus 2 cosecant squared of pi over 4. So let's go back to our previous page, and if we find out what we had earlier, we got the cosecant of pi over 4 to equal radical 2 and the cotangent of pi over 4 to equal 1. So let's just plug those numbers in. So I get negative 2 radical 2 because of here. Cotangent of pi over 4 is 1, so I put on the 1, and then I get negative 2 times the square of cosecant pi over 4, which is square root of 2 squared. And if I keep continuing, so let's do a new page, and I simplify this, I get negative 2 radical 2 minus 2, radical 2 squared is 2. So if I continue, I get 2 radical 2 minus 4. And this right here is your f prime of pi over 8. So our last step is to plug it into our equation. So let's full screen this. Right. So if I do this correctly, I get y minus our y value, which in this case was radical 2 plus 1, which is equal to f prime of x, which we found to be negative 2 radical 2 minus 4 times x minus pi over 8. So this is our tangent line. equation. If I read the directions, you'll see I also need to find the normal line. So what's the normal line? It's a tangent line, except my slope is a negative reciprocal, so let's do that, and I get y minus radical 2 plus 1. These are already negative, so if I want the negative of this, I want to change them into positive. I also want its reciprocal, so I get 2 radical 2 plus 4, and then I keep my x value. And this right here is a normal line equation. And that's the end of trigonometry. If you have any questions, please feel free to email me or send me a message and I can work it out. And when we return to school, we will practice all these trig derivatives together. Thank you.